Okay, so we already showed the data. So someone was asking me also about will we have access to the data, things like that. So the folder is just the stuff you need to start off with. Anything that's produced because you've put everything in the right directory, like different versions of saving the folders, anything that we're going to do will be produced in that folder. Okay, so that's one of the primary reasons why I'm trying to get you to go along with as we're going along, or keeping track as we go along, so that if you want to try reworking this data later tonight or some other time, you have access to it. Because I always give the basis of what I'll be calling in, or the primary things that we can't really pull in without downloading them first in that folder, but it's always just going to be those basics. If later on we create a new data frame and you need that to then try something, it's about, you have to enter those, the code that we have to basically have it in the right format to try whatever you're going to try. That's why you have to sort of do step by step with me, okay? And especially that's going to be very clear here, because this data set we're calling in is not something, well, I need to be clear on this. You can download a version directly into R, but basically, actually, if you're participating in the development portion of the ERSA, she'll actually be teaching that course, I think. But it's some work I did with her in terms of conflict, and this is the ACLID conflict database is basically taking as much information as possible from various sources, but typically it's from news organizations, the news feeds that basically feed in information and allow it to collect when there's some type of, in better ways, well, there's no good way to say it, basically some form of conflict. Usually there's different forms of how it's developing, but it's supposed to give you enough information to identify, in most cases, participants, how many people died, what was, who's started the attack, which is sometimes subjective. So these are all things that it basically collects, but and when you have this, you could basically take this information and try to pinpoint things that might be correlated with other events. And this one is very detailed. So it's not like at a state level. It wouldn't tell you the number happening in South Africa. It would actually tell you, with some accuracy for most observations, GPS coordinates of where it was occurring at, say, a district or even a very low micro level. And from that, you could then use it for other micro data sets that are of either the same type, or you could aggregate it up. So this is, the reason I'm showing this is basically to give you some idea of how we work with real sort of outcomes or real data that we've used in the past. So in this case, it's the GED50.CSV. Now this data set was downloaded about 3 years ago, so they've updated it since. And once you have this, you have a lot of different information. I'm only showing 5 of the particular outcomes, but we have IDs which aren't very telling, because the IDs are specific to the type of event and the actors and everything. You could use those later for classifications. But we also have the year it occurred. The year is active, so how long did it actually last? It can be just a random attack, or it could be actually a continuous event. And then we also have something that, in some ways, the reason I keep saying it's subjective is basically a person is deciding who attacked who, what type, they're adding that classification. But then you can also, but it does classify it as a type of violence. Usually it's, if I remember right, it's government on civilians, one-sided, or sorry, it's one-sided, government on government actors, and then group on group action. But the whole point is that basically we can have some information here, but it's very detailed. And then we can also ask for additional information, which it gives us, you probably don't, they give a name to the INS here, which I can't remember what that stands for, but it's an indication for a country, the dates, and then additional classification information here, but also the years. The point is that once we actually call the data in, what I call real data, but the other data was real, you start to get an idea that it is a little bit more of a headache whenever you have a lot of information in there. So let me show you on the actual R what this looks like. I just want to grab the, no, that's that, yeah, that's it. Oh, okay, it's way up there. Okay, I'll just call it in this way. That'll be. Okay, whoops. That shows a conflict. Give me 1 second. What's going on there? Oh, it's because it's not. Oh, yeah. Sorry, I've jumped ahead a little bit. So once we're in the ACLA data set, you see that we have some information that's given here in terms of the number of observations, 48 variables, but we can actually look at it a little bit more detailed without going through, the bottom screen there. That gives me sort of a rough overview, what you would usually see in some, Excel packages or Stata. But this is all the information, and this is exactly how it's called in. And in this sense, it's all the information's there, but I could then go through like before and actually look at the class. How is this actually formatted? Okay, these are formatted as date outcomes. So then basically I can tell it, order it by year, order it by events happening in particular months. Basically I could go through all that by doing different functions to set up the arrangement of what I need. So the reason why I chose this data set is because what we're about to do is we're actually going to use a lot of these functions. I'm saying sort of data manipulation to get in the right format, because with larger data sets, that's typically where we fret to even try, because as we get over a couple of 1,000 to 100,000 observations, we don't really like messing with the data too much because we see it as a headache. But the point is to let the program do the work for you. Let it keep track of how everything needs to be put together, identified, to allow you to have a little bit of a easier life than trying to keep track of the country and or in our case, not country, it's actually a very small micro level district or anything like that with a date, and then also classify it with a type of violence. So these are all things that basically you sort of need to start doing, especially as your data sets and everything start to expand. You can't do it just by looking at it and eyeing it. Okay? Okay, so that's just pointing out, basically this is a huge data set. You should not be working with it by hand. Okay? If that's what you want to take from this. So the objective is I want to sort of explore the ACLID data And to tell you the truth, out of the conflict databases that are available, this is one of the smallest ones. Another one that I use is in the few billion observations. You get a lot of stuff. So in this case, it's basically figuring out how to manage it. So basically, we want to see what happens by using the reader or Haven to bring the data in, or in this case, bring it in first and then read it as a DTA file. So basically, once we import it, we can either keep it as a CSV file or export it and then re-import it as a DTA file. Because like I said, I jump between programs because I find things easier in certain programs than others. When it comes to building data sets, I like doing it in Stata. So, I mean, there's different ways of doing this. Then we can also examine the structure using the string outcomes that we were looking for. This gives us classifications of the types of variables that are formatted or that we have in this data set. So knowing that format, because once we go to try to estimate, we have to make sure that we're not using strings. Regressions only like, numeric stuff, unless we define something as a factor. And then from that, we can actually go about saving in the various formats. And particularly, we can save it as an R file. Okay, so most of you kind of figured out the biggest problem that most people are having is that their directories weren't pointing in the right to the right place. So if you don't have that directory pointing to it, it's not going to find it. So the first thing to do before you kind of enter in any type of data is, if you know it's in a particular file, you do the get wd parenthesis, and that'll tell you which directory it's in. That'll tell you if the data is in a particular folder and it's not pointing to that folder, that's why it cannot find it. So that's for the first thing to do always, is to make sure that whatever directory you're in, that's where your computer's pointing. Once it's in there, then you should be able to call in the ACLID data. And once we have it, the first thing that I asked to do was string. Was that it? Oops. What did I do? Oh, I caught it. A lot of y'all called it GED or GED 50, and I just was using the same thing. And this is just giving you a glimpse at it. That's all it's meant to do. And it's the same thing that Duplar glimpse program is doing, the same thing. Like I said, there are tons of different packages that just basically mimic the same thing as others. It just has a different formatting. Okay? And then from that, we can basically go into the other side, which was we could do the summary, which everybody pretty much did. And then, like I said, if for some reason you want to call this in, you do need to save it as an RDS file. That is what R looks for. And usually that's for bigger files. You need it in a particular format, especially for speed, if that's what you're looking for. If you're trying to call in say a 500 megabyte file that's in Stata version or DTA version, it's going to take a while to upload. If it's already in the R formats, it's going to come in 10 times quicker. Okay? So was everybody pretty much successful in most of these? It's pretty straightforward. Yeah, so that's what's going on in the parentheses here. Now, a lot of the times I put parentheses like this, but that means you need to put the information inside what you're trying to save. So when you're doing this, you're actually going to be saving what the file is. Oops. There it is. So in this case, I need to tell it what it's going to save as ACLID. and I have to tell it what it's going to save it as. What's the name it's going to save it as? In this case, I could call it ACLID as well. And if I basically go back and look at the directory again, I should see an ACLID file. Okay, so now this is saved as R. I can bring it in and out of R very quickly because it's already in the right format. So sorry, when I do those parentheses, I'm basically telling you to put in what you're supposed to be putting in. It's not a, you know, it's not, you can't leave those parentheses empty, or it's going to return the defaults. Okay, the default, like for get working directory, is just going to return it back to it. So just keep that in mind as we're going through, because a lot of these things, when you're doing it, you have to know some of the formatting stuff. But remember the very first thing, the first way I showed you to sort of work with it. So one of the things you could do is save that RDS, which then brings up the help file and the format that you would need for any type of thing that you're doing. So in this case, it would tell me that I need the object, I need the file name, and I can actually tell it to change the format. What if I wanted it as ASCII and not as an R file? Okay, so this is where the help can really benefit you here. Okay? So this is, like I said, just sort of a test to sort of give you an idea of how you would go about this. You have an unknown data set. You need to bring it in. You need to try to save it, and you need to know some of the options. That's why the help is there if you get stuck with something. Okay? Okay? So, like I said, this is where we're starting out, because what we're going to do is now we're going to try to, again, manipulate this, but does not mean cook or massage. And what we're going to use here is tidyverse. Now, again, I've told you before, there are many ways of doing a lot of things in R. Tidyverse is very well supported and basically is a huge group of packages that try to help you to get it in the right format. Now, a lot of the things that we do for research, there's a few exceptions. There's always exceptions to anything. But a lot of this, what we need is what we refer to as long format. Basically, for tidyverse, when we're thinking about how we make adjustments, how we get things in a format that can be useful for putting up visualizations, tables, or even programs, is each observation or each variable has its own column, and each observation has its own row. Okay? This is what we mean by long format. Some of you are used to macro data that might be what's referred to as wide format, that you might have GDP 90, GDP 91, and all the way across, and then you have particular value or particular countries on the left-hand side. We refer to that as wide format. And some programs do need it in wide format, but most that you will be using and that I know of typically needs something called long format. And that's where, like I said, we have each variable has its own column and each observation has its own row. Doesn't mean that they can't be NAs or missing. It just means that that's the way the format is. Okay? It can just be a missing observation, but it has an NA or something there. And from that, we basically go and have all these particular options that allow us to do various things. ggplot, which I've already typed in once, but because I didn't have any data loaded, it was blank, is basically for visualizations. This is where you get the scatters, the box plots, all those things that look nice in most presentations. Again, somebody's going to make fun of me for saying it this way, but I call it Duplar just to be, I don't know if that's exactly how you say it, but basically this is where we do our data manipulation, where we do subsets. We combine different data sets. We sometimes, for lack of a better word, rearrange things, take means, medians, all those things. We also have tidier, which is called data tidying. We've already seen reader for data imports. And then there's a few others here that you're not really going to use that much until you start becoming a little more familiar with it. But this is not the complete list. This is an entire or huge area within R that basically is just for data construction, getting in the right format, and visualization. So just keep that in mind. Even in the duplar, we have all these different functions that allow us to filter, select, mutate, which is basically transform or create new variables in the same data frame. We also have summarize, which helps us create means, medians, things of that nature, and the group by. Now I'm going to do a lot of these things, and you're going to see it as I go through it. And I'll go ahead and tell you that it's not going to come easy at the very beginning. And most likely you're going to look at it and then basically want to, it's going to be best to sort of practice it tonight if you can, because it's not always straightforward. The other thing is, you've noticed already from the previous slide, you saw that I did something like where I put the 2 dots here. Sometimes whenever you're doing these programs, they sometimes get confused because packages might have the same function naming system, like the word select. Select can be used in different packages. If you only put the select, sometimes it gets confused which one you're actually asking for. But the way the structure of R is basically whichever package is loaded last gets that primary naming function. So if I want to use the duplar here, but there's another program I have that has select in it, then I have to do this to be able to tell it to use this particular function. It's typically not horrible for most cases, but because I load a lot of different programs, it becomes a little bit of a headache. So you'll see me that sometimes I do that just out of habit, not meaning that you have to. So I'll try to give an idea when that happens. So like I said, I'm not expecting you to know all this, and it's not going to come easy at the very beginning because it's not usually how you're used to constructing data. So we're going to do a little bit of practice with it as well. But the reason why we're kind of structuring this way, the way we think about tidyverse, is basically readable code. A lot of times when you're going about building the data set, construction, and everything else, you tend to do it in various formats at various times in your code, okay, for construction. One of the things that helps us with tidyverse is basically, or in this case duplar, is to kind of put everything together so that we read it as one portion of the code. But to do that, we basically use something called a pipe. Basically, it's a percentage term, greater than sign, percentage term. Basically, it says that at the end of the function, it's a continuation of the next set. Okay, so it's basically going to try to help us minimize the steps. So a lot of times, whenever you're doing different programs, you're basically first sorting. Once you've sorted, then you might merge. Or you might do a sorting and then you want to create means by particular groups. Those become different functions in the programs that you typically use. Here, we actually keep them all in the same chunk, as we call them sometimes. So that's where the piping comes in. Basically, it helps us organize and makes it a little bit more readable for what we're going to be doing. And, you know, at first it is a little funny to use, but it becomes a little bit easier as you go on. So basically we're just going to put multiple command functions or kind of chain them together to create whatever data outcome that we're trying to get. So basically just think that this pipe passes one function output into the next. Okay, so if I've told it to group something, then after it's grouped, it's being piped into the next function, and I ask it for means by that group. Basically, it's going to create the new variable that's a grouped mean. So it's just making sure that everything stays together. So just think about whatever object you have. Once you define the object, you're telling it to be fed into the function. Once this function is done, feed into the next function, and so forth. These, and it doesn't stop with this. I could have gone into like 20 of these. It can get very complicated very quickly, depending on how much construction you have to do. Okay, but like I said, it just takes a little practice as you keep going, so you keep practicing these things. Okay. So let's give an example in terms of the ACLID data. So if you're going to try to use this, some of you called that particular data set the GED 50, right? If you did that, and that's how you called it into R, that's how you called the object, the key is you have to change where it says ACLID there, you have to change it to the GED 50. Because that object is the first part. What you're telling it in that first portion here, yeah, here. Whoops, don't go that way. Yeah, you try doing it this way. What you're trying to tell it here is, this is the object I want to use. That's the end of the function. Then you have the pipe that tells it, after you get this, I want you to select these, what's this, 5 variables. And I want you to sample 10 of them. I just want to sample out of all the observations that you have within this data set, just give me 10 of them. Okay? So in that case, this new data set that I created, which was ACLID info, is only a random sample of 10. Okay, so just remember, object, function, once it's done, the next function. Okay, so this is typically what we mean by piping, or in terms of manageable data. So most time I would have had to tell it, you know, go through and select these as one command. Once it's finished, then I would go through and tell it, of those, sample and give me the outcome. But we're trying to put it all in one confined space. Okay? The next one is sort of the beginning idea of creating tables. Okay? It's called a cable. And again, like I said, there's a bunch of different table or functions out there that for tables that help us create something that's nice and neat. So in this case, when I do the cable, I just have to tell it what you want to basically print in terms of the data. I can tell it the caption information, and then this last little part is just telling it how big I want the text. Once you do that, I didn't do anything else to this. This is exactly what it printed. I know this isn't, you know, perfect in terms of what you would do for any type of research or what you're, you know, submitting, but it is the start of something that looks a little bit better than just working with Excel. Okay, this is and I didn't do any other. I didn't do anything else. I didn't go modify it at all. This is exactly what it printed. Okay. So in this case, this is what I mean by, one, it helps group and understand what you're doing in terms of the data manipulation. Second, it helps it be a little bit more manageable because I can do this and basically print what I need it to print. And then I could easily send this to a co-author to basically let them look at it. I know this is a simplified version of it, but at least this is more information than if it's just printed as output from R. Because if it was just printed from output from R, basically, let me just go down. Hold on, what did I do? See, this is where I was telling you there's a conflict package. So basically, I got a conflict between my select commands. And this is where I have to sort of tell it to make sure it uses the right function. So I could basically copy and paste this, or I could use the cable, which is more of defined output for me, okay? Either way is fine right now. It's mainly getting some practice with it, but these are just examples of how you might start to find a way of displaying your output in a little bit better formatting structure. Okay? What about, sometimes a data set might have every single country in the world, or it might have every single country in the world, plus it might actually do some type of aggregates. In that case, it might be better to, throw out the pieces that you don't need. If your focus is Africa or if it's Asia, why do you need to go through and keep the entire data set? You have a question?
Yeah, does cable staging have a package?
Well, yeah, there's a library for cable as well. Yeah, it's not. I don't believe it's a part of the base package. Yeah, you should go ahead and not only do cable, but there's one called Cable Extra, which adds a few functions as well. Well, this isn't a cross section right now. It's basically panel still. It's just a panel for a subset. So it's basically a way of saving something. So a lot of times if my research is focusing on Africa, why keep all the countries in my data set? Why not just subset it to the data that I need? So that's why and that's a lot of data. We do that a lot of times because we have areas that we focus on. And that's why you would want to do it this way. That's easier than just sorting and then going and automatically going through Excel and deleting by hand what you're doing. It's just an easier way to do it. Yeah. Okay. Okay. So in this case, oh yeah. So here is just subsetting. So one way of subsetting the data, again, if you loaded some of my packages and there's a conflict, you would need to put that DPLYR there because it's confusing a select with another one. But from that, basically I could tell it, okay, grab the same variables that I had before, but this time only keep those that have a variable region equal Africa, which is a part of my data set. So in that set, basically I allow myself to only focus on that region. Okay? And in this, I can basically look at it and see which data set or which countries and types of violence and years are in my data set. This is only the top 6 of those. And this is where I kind of point out that problem with the conflict between between the packages sometimes. Yeah.
When you use that last line, the head conflicts.africa, would it always be 6?
It will be, but if you change, you could do, I might have to change my code a little bit because there's a conflict, like I said, on my packages, but let me just change this real quick. I think this is right. I don't really do this a lot. Yep, I made a mistake. Hold on a second. No. I got to remember the structure of head. This is. Yeah, that's it. And see now it prints 10. I could do as many as I want.
Can I see the code?
Oh, yeah. Yeah, so it's comma n equal to 10. There's another way of doing it with the braces, but yeah. Sometimes, like I said, I jump between programs so I forget one syntax versus another syntax. Okay? So, and it's mainly, we usually do it just to check the data after a merge or anything else, that everything is sort of looking okay, at least for the first few observations. But it's not meant to be something that allows you, usually if you want to go further than that, you would need to look at names or streams or things to see more information. It's meant to be more of a quick check.
There's no code to check the button.
Okay, let me think if I remember how to do this. So, yeah, you would need to, not sure if it's this. I don't think it's this. It's been a while since. Yeah. Well, no, that didn't work. That's the wrong thing. I'd have to look at it. Most time, if I was doing it, I would basically just reverse the order by sorting the opposite way, and then I would look at the head again. So it just depends. Yeah, this apparently did something odd and printed the first 200 outcomes. So that's one way of doing it too, I guess. Hold on a second. Yeah. Okay. Okay, so just keep that in mind that these are helpful for this, but if you're going to use this program, you just need to make sure that you don't have any problems with conflicting packages, or you can just always have this here. If I have a lot of packages in there, that's what I do, just because I know I'll be using it a lot. Okay, so this is one of the first sort of steps of what's referred to as data manipulation. If my research is on a particular area, don't keep all areas that might then later confuse what I'm trying to do for regression or visual analysis. Because if it's in the data and you don't basically subset it, you could start to bring that information in that you don't want. Okay? So it's an easy way to subdivide the data, get it to just what you need and the variables you need. That's where the select comes in. And then you can start working from there. Okay? And it also helps a lot of times if you start working with really big data sets, you want to streamline what you're doing as much as possible, because once it actually starts running, the larger your data set is, the more memory and everything that you're taking up, the harder your computer is going to have to work. Okay, so streamline it as much as possible by getting it just to what you need. Okay. We can also, focus on ways of throwing out countries, or even in this case continents. Basically, I could select the same data sets and exclude everyone. I actually say excluding Africa, but I actually exclude Africa and Asia. Okay, I could basically go in there, and if I don't know everybody that I want to keep, but I do know who I want to not keep, I could basically do the reverse of what I was doing. Basically exclude them out. In this case, that's where you would basically do the same exact code, but if you're used to programming, you would know that basically an exclamation mark, which is there, is another way of saying not. Don't include this, sometimes there is a tilde that people use, but I only think that's for state. I'm not sure if it's for R as well. Okay, so we can't exclude information, or as we do here, we can actually start to combine information to get more statistics. So in this case, I could start to combine and take every single country in my data set and aggregate all the conflicts. Because remember, I told you this was a micro data set. We're actually getting internal information, and it's at a daily outcome. We actually, that's more information than we typically want. And so from that, basically, most of the time we only have information about the country at an aggregate level. And in that case, we need to aggregate them. So I already went through, and I know that the ISO-CC indicates which country it is. Okay? And I'm telling it to group by the ISO-CC and year. So once it does that, it's going to take everything after that as grouped information. Okay, so that's why, remember I told you this, like combining functions as you go along. You take the object that you started with, in this case ACLID, group it, and once it's grouped, everything after that is going to put out information that is specific to that group. Okay, so here I'm asking it to summarize. I want it to count the number of events within the data set. So if you're in the data set for that particular day, then that is a conflict. Okay, and right now I am not specific on the type of conflict. I just want to know how many events happen in the country, not what type, but just the events. Then once it does that, it's going to give me a new variable that's a count of the number of events. So I'll know the total number of conflicts within that country. Once it's done, I can basically say group again by year, and this time, from those, since I've already got the counts, I want to know from those counts the sum of the count again. So basically, I'm creating a share within that year. So how many? What's the share within the total of that count? Okay, so that's what I mean by basically you're going from one function to the next. Okay, so basically, I should point this out too. Before we're using group, we use summarize, but now we're using mutate. In this case, what it's telling it to do is to take the outcome that we got and create a new variable within this data set. Okay, and that new variable will be called share. So the share of the number of events. Okay, and and so from that, I'm not sure if we wanted in the particular. It's just trying to show different ways of doing this, but you could think of many different ways of doing this. I could have created the share by region or something else. Okay. We could also, I actually do the regions here. So aggregating total conflicts by region and year. I'm doing the same thing, but now instead of doing it by, creating a share by the country, I'm actually creating it by the region. Okay. And again, I could use the cable. I don't think I showed the cable here though. and printouts by region in 2015 what the count and the share of conflict was across the world. Okay, so this is what I meant by many times you would take these in different pieces within your data set as you were building them. But in this case, you can actually put all the information together and make sure it goes back and then is combined with your data frame. So it's just like piecing it all together. Instead of doing it in little chunks, you're actually just doing it as one whole. Okay? And so this is just another version of the cable. I just didn't print that particular program out. Okay, and then basically we have a few more things that we're just gonna show. Let me see how many I got here. Yeah. Yeah, 2:30. Okay, so the next is we have subsetting, we have creating new variables as we go along. A lot of times, like I said, pivoting or reshaping is one of the biggest issues that we have in combining or creating data. I've seen too many students basically just do a copy and paste and they sit there for hours doing this. But as long as we tell R in this case what variables to, the way it describes it as pivot, some people call it reshape, on, we can basically cut it down to a few seconds to where we can basically take it from a version that we, most of the time we're taking it from wider to long. But once we do that, all we have to do is define exactly what variables we're actually wanting to reshape it on. So in the tidyverse, we have pivot long, which takes it from wide format to long format. And pivot wider takes it from long format to wide format. Most of the time, you're basically going to be using this most likely if you're using regression analysis. And it basically gives you a version of how to think about this. If you have an IJ in long format, so we're thinking about this, I probably should have changed the J to T maybe or something, because we usually think about this as IT. So we have, whatever country or individual is, their observation at time T, or their, whatever time T is, and that gives us an observation, say GDP. Similar for the same country in the next year, what their GDP is. But sometimes we find it in this format to where we have all the variables that we're concerned with, the variable that we're concerned with, but we have just one country for that, we have all the countries, and then we have the GDP for, say, the first year for all the countries, and then the next one for all the countries. We can't do regression analysis typically in that format. It usually needs to be in this format. That's why it's very important that we find a quick and easy way to put it in the right format. Okay? So what I'm just demonstrating here, because our conflict data is already in long format. We have an observation, and we have a year, and basically we have the outcome. So basically, in some ways, it is a long format. But just to give you an idea of how we could modify this is basically to pivot wider. We could basically still go through using the pipe to group by particular countries. This code should have been put with the other one, sorry. It shouldn't be on this format. We'll start here. So basically, I wanted to pivot wider in 2015. I don't want to do all the years because it just gets too long. But by doing this, I can basically filter on a particular year, 2015 here. I'm telling it how to adjust, in this case, adjust on the ISO codes. And basically, the values come from N. So actually, I didn't need this here. I just needed the count or the number of events. And from that, I can then, this is as important to select. It's just so that this table is very small. But you can see that before I had a year, and then I had a country, and then I had a number of events. Now it's been shifted to where I have a country, number of events, country, number of events, country. So it's no longer what we refer to as tidy. A variable doesn't have one column, and the row is an observation. Here, each country or the unit observation is the column. It's what we refer to as not being tidy. Okay? So I wanted to give this because we can't really switch the other way around because our data is already in the long format. But like I said, this only takes a few seconds versus trying to do it by hand takes a very long time. Okay? So that's a version of the reshape. So basically the way we like it in long format is each column is a particular variable. So a column would be GDP, and then the row would be an observation. So if our units are, say, countries, and then we have years in there, then it would be a country, year, and then the GDP outcome. Then it can be the same country, but a different year and an outcome. But in a wider format, what you typically have is the unit of analysis here, and if there's a time, it's on, well, actually it could be either way, it depends. But you could have a country here and year here, and then that would be the outcome for that particular country in a year. So each of those would be not a variable in the column. That makes sense. I mean, I can show you the difference. It's basically that, yeah, I probably should, actually, if you don't put year in there, don't think about it as year. Just think about it as you have a country and an outcome for a particular variable. What we have is a country, the variable, say GDP, and its outcome. Next country, its outcome. Then we have, say, investments on the next column, country outcome. And then the next row is a different country's outcome. A wide data set would be, say, countries and year, but then the first observation on that row would be that country's GDP. And then the next one, basically you would have all the years, year. It's funny whenever you throw years in there. It messes up the formatting issue.
So are you saying that when your variables are going from left to right?
It's a bad way, the way you're describing it is a bad way to think about it. It's,
Can I please see the difference? So that I can understand?
let me see if I got it here. Let me just create this real quick. No, not that. Let me just run this real quick. No, hold on, that's not the one I want. Yeah, that's the one I want. Yeah. Sorry. I'm going to throw this out real quick. Let's want this. Oh, hold on, what did I do? Oh, come on. Okay, so if I was looking at the conflict, it's this one. See how it's structured? I have a year on the left-hand side. It's a column by itself. And each of the countries is a column by itself, right? It's going all the way across. In the wide or the long format, it would basically be conflicts going down and country going down. So the conflict is its own column, and each observational unit has an observation as a row.
And look, I'm still confused.
It's something to get sort of used to. Let me see if I can do. Okay,
So the structure changes or it doesn't change?
well, the structure changes because of how you modified it, but let me just do. I haven't done it this way in a while.
So instead of year going down, then it would be year going across.
No, it's just year is still kind of going down, but it's a different structure. Yeah, let me try to do something real quick. Let me just. This might not work because I'm doing it on the fly, but it's better if I let me rework it and then I'll show it to you a little bit later. It'll be the best way. So, like I said, it's hard to think about it as year when you do it. But think if you just had one data set of year. Don't worry about the column for year. What basically you're having is everything that's going across is a unit of observation, and you have a number for that, right? What's happening is, think about if you transpose it downward. Another way of thinking about it is that. Then what you have is A, B, W, C, O, L, and then you have, so if this is the conflict variable, each variable has their own column, and each row has their own observation. So in this way, it's basically doing this way. And then if you had year, so say that these were all 2015 here. So you would have another variable or column in this case that say 2015. Now that's still a variable. So when we do ABW again and a number, so this is 2016. Like that.
So this would be
Yeah. If we were trying to do it in this format, though, the way it would be we'd have ABW again, COL, but this year, 2015, 2016, so each year being added is pushing it down this way. Okay. But usually for regression analysis, we need it in this sort of format. That whatever observation we're kind of looking at on the left or the right, that it has one and one alone observation. Okay? Because that's what we're feeding in as the column. Okay? So in this way, that was for reshaping or pivoting. What we do also have here are merging. Now, this, if you're not having any merges whatsoever, that's kind of strange because basically no data set is really complete unless it really is the primary data. It's, we need to add in information from other places, country information, city information, whatever it is, that combines it with the data set that we're using. So a lot of times when we do that, we can use various forms. One is left join, right join, inner join, full join. They each, depending on what you're thinking of how you're wanting to keep things afterwards, because really, unless you're coming from the same place, there's never a good merge, as we call it. There's going to be some, information missing that doesn't match up between the two. This case, if we're doing a left join, we're basically saying keep all the rows that are in your left data set and merge them with what's in the right data set. But if there's no matching rows in the right, or what's not matching in the right, throw it away. Keep only what matches in the left. You could do the same thing for the right. Typically, it works in the same way. It's just, you're throwing out the things from the left. And then inner join, basically return only rows that have matching keys for both data sets. That means if there's, basically there's a match on the left, but it's not in the right, still throw out the right because we only want to keep everything that matches perfectly. And then we have the full join, which basically says put them both together, match what you can. Anything that doesn't match, put an NA in there. Okay? These are all, we have different reasons for doing each one. It just depends on, again, what our particular question is. Whether that variable is important, whether it's something that we could get information from somewhere else to supplement it, that basically would fill it in. So these are all reasons to do this, or it depends on which one you would need to complete what you want to do. The important part of this is to know both data sets well enough to know if something's missing from one of them, you notice why. Okay, so you always want to know why something did not merge correctly. And typically, whether you're doing left or right, usually you want to take whatever the biggest data set is, the most complete in terms of observations, years, or whatever. You want to be merging into that version. That makes it a little bit easier to, figure out what's going on. We could also do the bind rows, but that's the reason I'm not showing an example of that is because basically it's what we refer to as appending. Basically, you have two data sets from maybe two different sources, but they have the same variable names and things. We could just plop it down at the bottom and basically say it's additional years or something else. And basically we call that an append. Basically, we're just plopping it at the bottom or top, however you want to say it. When we come to identification, this is where it gets important, that you need a common identifier for the cross-section in this case. A lot of times, the things that we have problems with is basically that we're trying to combine things that have not been formatted for the right. They have a common identifier. They might match, but the variable names are different. That's where you either need to tell R that these are the same variables, just I called them different names, and which name do I want to keep. Or you can just change the variable name that to whatever you want in both sets so that they both match. And in this case, it's basically this, if you need a panel, we're going to need two common identifiers here. The unit under observation as well as whatever the time outcome is, in this case, year or whatever. So you have to tell it this because it's not going to guess for you. You have to let it know what you're combining. So example is I wanted to, and by the way, this isn't something you probably should do. It's just, it was two data sets that were available, so it was easy to grab. So I'm going to use GDP per capita drawn from the World Development Indicators. And we can actually do that again. Like I said, you could go and find it on the internet and download it and then import it using the CSV command that we used earlier. Or you could actually just call it in directly using the package WDI. And so, it's a little bit easier to do that. And I've mentioned it, but the thing is, there are so many data sets that you can actually just pull in directly to R that it's meant to be more helpful for you that way. Okay? And so I typically try to do that if possible because I can't tell you how many mistakes I've made by downloading the data. Either the data has problems or I just did something wrong when I downloaded it, and then it ends up with a big issue at the end of my project. Okay? There's less, it can still happen, but it's less likely to happen whenever you can draw it straight into R. So to merge, like I said, you need a preparation. You need to know which identifiers are in which data set. So I've already told you the country identifier in the conflict data was ISOCC. And then that identifier is the same in both data sets, so they're both year. This, and by the way, this can be thrown off if one is in capital and one is not. So capital Y-E-A-R versus lowercase for all. They have to be exactly in the similar string to be able to do it properly, unless you make adjustments. So what I did was I called in the law, or I called in the GDP per capita in constant $2015, and then I logged it. So, and I did it all, like I said, in one little piece of code. Basically, I called in the conflict information. I renamed the ISO CC to ISO 3C. I grouped it by the ISO 3C in the region and year, and then basically created an aggregate of the number of conflicts in that year. So the WDI is yearly information. The micro data set, multiple outcomes per year for a country. So I could have left it that way, but then I would have, here's a conflict, here's a GDP. Here's another conflict in the same country, just maybe a few miles on the road, with the same GDP. And it would have been repeated over and over and over again. Wouldn't make a lot of sense to do it that way. So that's why I did the aggregation first, so that I have a one-for-one match. Okay? So once I created that, then I was able to bring in using the library WDI, I was able to bring in, or actually I did a search first. I needed to find, I'm not sure if you ever dealt with WDI, but their naming structure is a little strange, to me anyway. The indicator's call is ny.gdp.pcap.kd. Like I would ever remember that. So one thing you can ask it to do is I can do a website, or actually can search this data for phrases. In this case, GDP, along with capita, along with constant. So I'm basically looking for some measure that's constant. In this case, it's been weighted, or deflated. And I need it to be in per capita terms so that it's per individual or population. But once I did that, you can see that it gives me a lot of choices, and these are all the ones that came out. So I could have got it in constant 2011 dollars, or international dollars actually, 2015, which I used. LCU is, I always forget what that is. No. And then international dollars and 1987 international dollars. So basically these are all the choices I could have chose from. Once I have them, I can basically tell it to grab that particular one for GDP. And then I can also make sure that everything's matching in terms of my information. So I've already modified the log GDP capita. Okay, so these are just getting everything in the right format. Remember, you need that before you start merging things. It has to be common across. So once I do that, then I can basically do a left join in this case. In this case, I use GDP, or the data set that I downloaded from WDI, because I know that every possible country that's in there is it's like 230 countries, I think. It does countries, regions, all that. But the conflict data is only 140 countries. So, and it's a lot shorter time period. So I know that, the GDP is going to be a larger data set, more complete. So it's better, like I said, to merge into the more complete data set. So in this case, I did a left join with GDP as my left and conflict as my right. My identifiers are the ISO 3C and the year. This is panel, so I need two identifiers. The country is the unit of analysis, and the time, in this case, T is year. And then I can actually look, if I want to, and see how well the match was using something called anti-join. But basically, it just gives me some information on, how much or how many bad ones did I get. In this case, 457 bad matches across. So, it's like the regular merge like you've done in state or other places, but there's like I said, some preparation beforehand. In this case, you can also, like I said, go through and actually try to summarize different outcomes to see what percentage was missing and all that stuff. But this is one of the crucial steps when you're trying to build a data set. You have to it's usually not standalone one data set and you do all your research from there. You're usually combining with various information. So again, you'll get used to this. I usually try to practice a few of the things, especially for anybody that's taking a nap or anything like that. What? I didn't say anybody was, just in case. So we're going to basically try to apply some of these techniques. Whenever you tell it what data set you're starting with and which one you're merging in, doesn't matter if it's right or left, however it goes. Basically what it's going to do is it's going to take the 2 columns of information you give it, or even one if it's a cross-section. And once you have that, it's going to read both of those columns. The R is going to read both those columns. Then what it's going to try is going to sort them and try to match them across. And so that's where, it's basically in that sense doing that. So once it finds a match, and it finds a match here, it puts them together, but not, when it puts them together, it's going to keep whatever information, in this case GDP, and it's going to throw the column in a conflict beside it. And then it's going to keep doing that for all the observations that it matches. And if it has a time unit, what it's basically going to do is do the same thing, but it's going to make sure that the year matches in each of. It's going to make sure the country code and the time code match before adding in the column. If it doesn't find, say, remember I was using ABW here. Say there's ABW in 2015, but not in 2016 for whatever reason. What's going to happen is that conflict variable that would be there would be NA if I tell it to use the right join, because you put GDP in conflict, right? You did it that way. You said GDP is left, conflict is right, right? So if I told it to do a left join, an NA would not show up because you've said if it's not in the left, sorry, I don't know if it's in the right but not in the left, don't keep it. You can try to merge in cross sections into panels. You can do that. It's just going to be that the panel is going to be repeated values. It's going to keep repeating that value every time it finds the ISO code. So it's about what type of data set you're trying to structure. It only comes with practice. It's kind of hard to describe.
Also, so here, the reason why you're using 2 is because you want to read it in year. And do it if it's appearing twice or 3 times.
Well, it's because I've used two data sets that are technically panels. One, the WDI is going to be a balanced panel. The conflict is going to be an unbalanced panel. But the point is the unit of identification is a country and a year. That's why I'm doing the merge in that way. If it was just a cross section and it wasn't repeated on a yearly basis, then I would only merge on ISO to make sure, because it's about how many units. So the unit of identification is, if it's just a cross section, it's just the country. But as soon as you have a country 2015, a country 2016, and so forth, now the unit of analysis is being followed over time. So that means it's basically 2 dimensions, unit and year. Yeah, so that's why you just have to modify it. And it doesn't mean that, this is the only way to do it. You can actually have multiple dimensions as well. So you have trade data that's bilateral is actually 3-dimensional. It's an exporter, an importer, and a year. So you can get multi-dimensions as well.